everyone. Welcome to today's webinar, which is about designing for in-building wireless into commercial buildings. I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar today is presented by CommScope. Before we get started, I'd like to cover a few housekeeping items. Please note the control panel that is on your screen. This is where you can submit questions in the question box that's contained in that panel. Please send your questions in at any time, and your speaker will address them after the presentation. Also, please note the orange arrow on the left side of the control panel. Clicking on that arrow will either expand or collapse the panel, so please be sure it is expanded so you can access that question box during and after the presentation. If at any time you experience a technical difficulty, please send the message to us in that question box as well, and we will address it right away. Also, if you're interested in receiving a copy of the presentation today, please send us a note in the question box and someone will follow up with you as well. Now I'd like to introduce your speaker today, Brian Domingo. Brian is a business development manager for CommScope's Distributed Coverage and Capacity Solutions division. He works with several customers and internal personnel to help identify the best methods for marketing and selling wireless coverage solutions. Prior to CommScope, Brian worked in several roles from senior RF systems engineering to sales. He has worked for Sprint, Motorola, Agilent Technologies, and Andrew Corporation. Brian holds a bachelor's degree in electrical engineering and an MBA from the University of Illinois at Chicago. So with that, I'll hand it over to Brian. Welcome, Brian.
Thank you, Ann. I appreciate the introduction. And thank you, everybody, for joining us for this webinar that have tuned in on the internet here. So I appreciate everyone's time. Over the next 35 to 40 minutes, I'm going to be covering the topic as displayed of what you see here, which is designing for in-building wireless in commercial buildings. So as we move forward in this slide here, just wanted to give you a little bit of an introduction regarding our organization. For those of you that don't know CommScope, CommScope is a market leader for network connectivity solutions. We are basically responsible for every core component that is currently deployed in major telecommunication networks, both from a wireless and wireline perspective. CommScope not only designs and manufactures the equipment, but we also offer turnkey engineering services to deploy these networks and also help work and support with other companies that focus on turnkey engineering solutions and services too. We are a global organization, roughly spanning about 25,000 employees. We are a publicly traded company approaching $5 billion in annual sales. One thing that CommScope's pride itself on is the fact that we're a very technology-driven organization with over 10,000 patents globally. We invest very heavily in our research and development efforts with roughly about $200 million invested annually. And since we are a global organization, to further enhance our depth and reach towards our customers, we have over 30 manufacturing and distribution facilities worldwide. One thing to note about CommScope as far as our core equipment that's used for major telecommunication networks, anything that's involved with a wireline or wireless network for communications, CommScope is involved. So we basically are where your networks are. All right, so we design and build connectivity for the world's most advanced communication networks. Behind every single enterprise customer or any customer that utilizes any type of wireless or wireline technology, we are the prime reason why major networks or major customers utilize our core equipment. From data center networks to building and venue networks, CommScope is at the heart of a lot of these infrastructure. For the topic of today's discussion, in-building wireless for commercial building, we're going to focus the topic of discussion in three key areas. First, we're going to focus on wireless trends and challenges for the enterprise. Next, we'll segue into discussion points, and we'll provide you a really good overview on understanding building wireless and alternatives and solutions. And most importantly, once you have a good understanding of in-building wireless, what are some recommendations for choosing the right in-building wireless solution? So with that being said, let's talk about wireless trends and challenges for the enterprise. In-building wireless is becoming the fourth utility. Now, what this means basically is it's instrumental towards efficiency, it's instrumental towards and impacting everyone's daily life. I'm pretty sure everyone on this call has some type of mobile device. Above and beyond just voice and data communication, there's a lot of reasons why enterprises are looking at enabling in-building wireless systems for their organizations. One thing to note, if you pay attention to the graph on the left, one thing that's very true and has been for quite some time is that global mobile data traffic has been increasing from 2016 and is projected out until 2021. We've analyzed that there's over a 600% growth over the next 5 years. You can see that the trending is almost like a hockey stick type of trajectory, and the reality is that demand continues to increase. The reality is that a lot of these services are not only street level in the outdoor environment, but a lot of it is being pervasive in indoor facilities and indoor locations. The graph on the right shows the effect of in-building wireless on building value towards the facilities or towards buildings where enterprise customers work on a daily basis. In-building wireless is almost becoming a key differentiator as far as why enterprise tenants decide to move from one location or another. Property management organizations and several enterprises are now making decisions on whether mobility services can be enabled or used within these buildings. Our research has shown that basically the function of an in-building wireless system being made available inside a building almost increases that value by over 86%. And the pie of where the area does not increase value is slowly dwindling. So we're seeing a higher and higher demand towards making sure that in-building wireless systems are pervasive for every organization in the world. Now, in-building wireless matters for all different types of businesses. In various vertical markets, you can see how the introduction of mobile technology has evolved organizations. From a business perspective, whether you're growing top-line revenue, increasing sales, in all aspects in all businesses, you can see a direct impact for mobility. In other areas of the business, whether you're streamlining operations or trying to keep costs down to increase profitability, there's a direct impact towards enabling wireless services for every organization. The reality is that business transpires both in an indoor and an outdoor environment. Wireless data networks have been built today to strictly support outdoor networks, but the demand for in-building wireless is growing at a higher rate, and the need is definitely increasing year over year. So some key examples include some vertical markets. For example, in hospitality, major hotel chains are enabling mobile applications to improve the interaction with their clients. Mobile hotel check-ins are becoming more pervasive at some of the major hotel lines that are actually out there globally, especially in the resort and hospitality services area. In healthcare, hospital communications have improved year over year, from remote surgical centers to enabling clinics to even the application or point of care. Several of these applications have been defined or have improved where patient care has never been or has basically never been involved in certain situations. So key communications, including medical records, are now flowing seamlessly to very high, strict security standards, but all enabled through mobility. The retail sector is increasing a surge of top-line revenue, not only with the advent of internet shopping and marketing, but also the retail experience is being improved and utilizing operational efficiencies through Internet of Things technologies, IoT technologies, at the point of sale couponing. The whole goal is that retailers are looking to improve and understand their customer demographic better, all through the use of mobile technology in the indoor environment. And last but not least, at a general scale, businesses. The bottom line, office productivity will increase, definitely if there is in-building wireless technology pervasive to reach your customers and for your customers to reach you.
Thanks, Brian. And with that, I believe we have a poll that we'd like everyone to weigh in on. You'll see that on your screen. And that is, for you, which is the biggest challenge to deploying in-building wireless systems, or what do you find to be the biggest challenge to deploying in-building wireless systems? Please take a moment to choose one, and we will show the results in a few moments. Technology is too complex, cost is too high, lack of support from service provider, or it's not needed. Okay, and we'll see the results in just a moment. And let's see. The leader was 53%, more than half, cost is too high, followed by 25% of you indicating lack of support from the service provider, followed by not needed, and technology being too complex. So there you go. Thank you very much for participating. And back to you, Brian.
Okay, great. Thank you, Ann. Thank you for participating in that poll. And if we switch over to the slide that you see right now, as great as in-building wireless is, and as much as we know that there's a huge demand for it, what's interesting is the previous research that we've done over case studies with research partners and what we've done with our existing enterprise customers perfectly coincides with the feedback that we received from everybody on the poll today. All right. What you see displayed on the slide here are the key challenges as far as what's preventing in-building wireless from actually hitting the market more effectively. Clearly, cost and complexity of the technology are the driving factors, right? There's a perception out there that cost is one of the major factors. And as an equipment manufacturer, CommScope is definitely geared towards making sure that we manage our operating margins to design equipment that's cost effective. And we look at the cost model of most of these DAS systems. We approach it from a total cost of ownership perspective, which is broken down into capital expenditure for the cost of the equipment, but at the same time, understanding what is it from an operating expenditure perspective moving forward for lifecycle management of the system. One thing you'll note is that a lot of the DAS systems or wireless in-building systems that are being commissioned into the marketplace, a lot of time is being spent by key manufacturers to improve the efficiency of these systems. So the bottom line is we want to make sure we improve that return on investment. So from a cost analysis, several things need to improve to make it more effective for our enterprise customers. Now, the complexity of technology, with the introduction of any technology at first infancy or first introduction, there's always a sense of complexity. And up until we define and understand the user demographic or the use model of where these technologies will be pervasive is where we can simplify the technology. CommScope's spending a lot of time developing software enhancements on their system, plus at the same time making sure that the deployment model for these systems are a lot more effective. And towards the tail end of this presentation, I'll discuss with you several of these items that we're doing to go ahead and address some of these challenges. But naturally, the network operator in other areas of understanding DAS systems becomes an issue. And this is where communication, training, and common understanding of the DAS systems by each of the manufacturers and consultants in the industry become very important. So moving beyond trends and challenges for the enterprise, the next thing I'd like to cover is to give everyone on this call a better understanding of what the wireless alternatives, the in-building wireless alternatives are, and what various solutions are made available. So when you think of in-building wireless, the fact that data is being transmitted with no cables being attached, there basically are three key solutions that the enterprise or the commercial building space definitely understands or is being introduced. The key areas of technology include Wi-Fi, which most enterprises typically have deployed or has been common ground for enabling connectivity to the internet for different types of appliances or peripherals such as PCs, laptops, or with the advent of PDAs a couple of years back and now smartphone technologies. Wi-Fi is a great technology that allows for that seamless flow of connectivity to the internet. Other solutions that are coming to market that I'll go into detail include distributed antenna systems or DAS systems, which are dependent on a specific radio source by each operator to pervasively distribute their signaling throughout a building, and small cell technology that is typically launched from a single operator perspective and caters towards a certain type of demographic when we talk about the size of buildings and the size of businesses. So let's go into additional detail on each of these type of solutions. Now, for those of you on the call, I may be preaching to the choir, but the reality is let's really take some time to understand the core basis of an enterprise Wi-Fi network. Now, often at times, everyone that's on this call and everyone that is in any type of mobile environment sees Wi-Fi as a pervasive way to connect to the internet. The key here is that the driver was simplicity. The fact that a system ID or SSID is being broadcasted by a Wi-Fi access point and the actual PCs or data devices have the technology to connect to that type of technology made it very, very effective and easy and simple to connect. What you see here is the core architecture that typically is used in most enterprise Wi-Fi deployments. First and foremost, it's about connectivity to the internet to connect within an organization or into other places, organizations in other locations, or to people across the world. So the key here is to try and get the internet service into a building. First and foremost, some type of service providers provide some type of direct connection into the premise by utilizing some type of Ethernet switch or controller based off of some type of routing technology. From there, the Ethernet switches typically are responsible for communicating to multiple switches within a building that are connected via various types of media, including cabling solutions such as Cat5 or Cat6a cabling. Plain and simply, it's a wire line network that has different ports within the building for connectivity of various peripherals. To wirelessly enable an enterprise, what is deployed is a wireless LAN controller, as what's illustrated on the presentation slide at the very bottom of the floor there. And the wireless LAN controller then utilizes the Ethernet switches to connect to multiple wireless access points throughout the building. The wireless access points are connected via a wired cable, but at that point, the wireless access points emit the data transmission to each of the different types of peripherals throughout the building, wherever that mobile user is in a fixed environment. Now, one thing to understand here is that the enterprise Wi-Fi environment is confined within that local premise, and often at times, seamless mobility isn't guaranteed, or there may be a degradation in data throughput as a laptop user, mobile user moves from one area to another. But enterprise Wi-Fi has been pervasive, and it's a great way of, quote unquote, cutting the cord to allow you to have that flexibility within the premise. The next core technology is distributed antenna systems, or DAS. Now, as a comparison to the enterprise Wi-Fi network, the enterprise Wi-Fi network's number one responsibility was to go ahead and promote enhanced mobile data services. So if you're an enterprise customer, or if you're a worker within an organization and you need to utilize your enterprise applications, you'll be able to attach to the network in a mobile environment within the premise. Mobility is contained once again in an enterprise Wi-Fi network within a building. Now the challenge is when we're looking at mobile device data and voice network technology provided by some of the tier 1 wireless service providers in North America and the United States, including Verizon Wireless, AT&T, or T-Mobile, or Sprint, or any other provider out there. The key to get that mobile device to work pervasively from outdoor to indoor often at times is challenging, or solutions are very limited in a Wi-Fi network. At that point, if enhanced mobile device data services or voice services are needed, the use of a distributed antenna system is optimized. What you see here is the exact same type of building, but this time utilizing a DAS system to be deployed in the entire building. First and foremost, the mobile operator network on the bottom left-hand side is the core switches and network that need to get its service from outdoors into the building. Typically, there's some type of connectivity transport that's provided by the mobile operator network to get that connection to the building. At the very bottom of the building, each mobile operator is going to deploy what they call mobile base station radios. In this illustration here, you see them defined as SP1, SP2, and SP3 with respect to each individual service operator. So SP1 could be Verizon, SP2 could be AT&T, SP3, so forth, so on, could be a separate service provider. The point is that the mobile operator needs to provide a radio source or radio network on premise or some type of connectivity to their network in the building. Once those radio sources are now made available, they interface and connect to what we call the DAS head end. The head end is responsible for interfacing with those various radio sources from each of the different service providers. Once the service providers successfully connect their radio sources to the DAS head end, the DAS now communicates to multiple expansion nodes located on each floor, connected by some type of physical media. Typically, this type of physical media could be some type of Ethernet connectivity, or it could be some type of dedicated fiber optic switch technology. Each expansion node then has some type of connectivity to various universal access points, which are the radio layer that propagates the radio signal that each mobile device can now use to connect to each respective service provider. The very important thing to note here is that one DAS head end can interface with multiple service providers. And as a result, the universal access point can also support multiple service providers. In this situation, all DAS systems utilize only one universal access point per discrete location. As illustrated here, we have 4 at each discrete what we call node location where it's providing coverage. Each universal access point can support multiple service providers from day one. So if there's a game plan or a strategy for only providing service for one provider, that'll be supported from day one and can expand to multiple operators and can scale and grow depending on the needs of the premise. The best analogy to understand a DAS system is to look at it as if it's plumbing that's pre-wired for a building, and all the operators have to do is plug their radio into the head end, and their service is pervasively distributed throughout the entire building. The next core technology is what we call small cells. Now, similar in architecture to the connectivity portion of a service provider providing its radio interface to the actual building itself, the mobile operator will connect to the building via some type of dedicated connection via the internet. Once the signal reaches the actual building at the very basement level, it utilizes some type of small cell controller to interface with various small cells that are deployed throughout the entire building. The difference between a small cell versus a DAS system is the fact that a small cell is dedicated per operator, per band, per technology. So as a result, if an organization wants multiple service providers to provide all of its services over 3 or 4 service providers throughout a building, there will be a need for multiple small cells at each discrete location. The small cell controller would distribute its signaling to the small cells via Ethernet switches that would be used very similar to a Wi-Fi deployment, but often at times the Ethernet switching technology would be very proprietary by the actual small cell provider that's enabling this type of service. One advantage of small cells is the fact that it's cost effective for a service provider to provide this. The only downside is as capacity grows or number of users grow within the building, and if there really is no flexibility towards allowing multiple operators until they deploy additional small cells for their own independent network. Now, we developed this slide here for you to understand all the different types of alternatives, but to compare them across the border. So we've covered the Wi-Fi enterprise deployment technology, we've talked about distributed antenna systems, and we talked about small cells. What we've come up here are basically 7 key items that kind of cross the span of the different technologies to help you get a better understanding of the core technologies. When we talk about network type, this is the type of technology or the type of management that's used by the service providers to enable connectivity to the internet. Wi-Fi typically uses what we call unlicensed frequencies to provide its service across multiple devices. The FCC, the Federal Communications Commission, early on, when they adopted Wi-Fi to be granted use in various segments throughout the world and in the United States with other governing bodies, they designated specific frequency bands that could be used for Wi-Fi deployment. The fact that it's unlicensed can be used and can be used by multiple users. But the only downside is since it's unlicensed, there's no one really operating or maintaining the quality of that signal. DAS systems, in comparison, DAS systems and small cells utilize core network type of technologies that are owned, managed, and operated and maintained by various service providers. The service providers use licensed frequency bands. For example, 4G LTE technology or 3G technology are all technologies that are owned, managed, and maintained by service providers. And what they do day in, day out is maintain and operate the frequency bands to make sure that there's minimal interference to improve and enhance an end user's quality of service. So that's a big difference between core technologies that are managed by the service provider versus unlicensed frequencies for Wi-Fi. And there have been noted personal experiences for everybody on the call and even for my personal self that once you load a Wi-Fi network, you will notice a little bit slower bandwidth that actually occurs for every end user. Now, as far as service providers, the Wi-Fi equipment is typically owned by the enterprise end user, so there's no service provider that typically is dedicated to that type of technology. Now, DAS systems utilize either a single or multiple service providers, so it gives you that flexibility to change or to add and provide a variety of service providers to support their distributed technologies. And what was stated in the previous slides, small cell technology typically is dedicated on a per service provider basis. So hence, if you want to have multiple service providers in a particular building utilizing small cells, you're going to have to deploy additional small cells dedicated for that one service provider. Now, from a voice perspective, there are very limited solutions for Wi-Fi. Wi-Fi, voice over Wi-Fi technology is making its name as a possible solution, but the reality is since over unlicensed frequency, the class and quality of service isn't as clear as if it was maintained on the licensed spectrum type of network. Voice services are definitely offered by DAS and small cell type of technologies, since they're owned and maintained by the service provider. Data and internet connectivity solutions, as far as services and offering, is bundled on the mobile device, but is also distributed to each of the core technologies, such as DAS and small cells. Access methods, typically a Wi-Fi deployed model within the enterprise, is maintained by IT policy managers within an organization. You typically have to self-authenticate and is usually automated within a certain time window, but once again, that is maintained by the IT policy managers or the technology group that's managing that dedicated Wi-Fi network in that fixed proximity. In comparison, the access methods for DAS and small cells are all maintained by the service provider. So as a result, to access those networks, it's automatically passed through within a premise to the service provider. So all the privileges and all the services that you sign up for the various wireless service providers will automatically pass through to each of your handsets. One thing to note, though, from an enterprise network perspective, Wi-Fi is really built for that type of model, where when you want to control the amount of data traffic and the core information that's being transmitted within the premise, Wi-Fi is built, since that is actually built for that technology, since that is really maintained by the actual IT policies within the organization. But from an enterprise perspective, there is no level of control at the enterprise level for wireless and mobility services that are being invoked through a DAS or small cell, since the authentication and security encryption are all being driven by the actual service provider themselves. And of course, when we talk about end user support responsibility in a Wi-Fi deployment, enterprise or venue owners typically own that responsibility, while from a support perspective for your mobile device, the mobile operator owns that service and maintenance for your handset, and the DAS and small cells are just extensions of those mobility network. As a result, they own that responsibility. So this slide is definitely a very good reference for you to understand the different core technologies, and you can see that there's key differentiators when you look at what type of solutions are provided by the mobile operator versus the enterprise network. Now, one thing to note is that DAS is becoming more what we call enterprise friendly. There's been a lot of evolution, a lot of research and development on understanding the usability of the different types of components that are usually built within the DAS system. And the whole goal right now is to mimic and model the enterprise environment versus the macro level wireless service provider environment. First, when we look at universal access points, typically one single remote will support all operators and frequencies. The important benefit here is that the operators provide flexibility and usability and aesthetics. The core technologies that are used for transmitting signals throughout the DAS and distributing it are now becoming digital versus analog. Analog systems typically have its limitation from a signaling loss perspective, power loss over long distances. So digital technology definitely improves the design and efficiency of managing the signaling and the network dispersion of the signaling throughout an enterprise. Various cabling solutions have been developed. What we wanted to do was incorporate the use of IT cabling, traditional Cat6A, and various fiber optic type of networking components within the enterprise. rather than utilizing analog coaxial cable, which can be very bulky and very difficult to install, but at the same time can be limited as far as utilizing various cables for different lengths and distances and runs. And as a result, you could really reduce your material costs on the actual deployment of the entire data system. Some key areas that are trending where we're showing a lot of development is in the management tools area. A lot of data systems that are coming to market are becoming more intelligent. So various software tools for configuration and management are automating the procedures where there's a lot of manual hours being done to either install, maintain, or optimize these type of networks. And as a result, because of this development, there's easier setup and overall long-term operations of the system are a lot more efficient. Infrastructure sharing, for example, using the core backbone for Cat6a technology, for example, can be utilized not only for the enterprise application layer for enterprise servers sending signaling throughout a building, but that same infrastructure could be used for a DAS system. So sharing this infrastructure reduces costs and reduces the number of issues that actually may happen. So there's some key benefits with utilizing infrastructure sharing. One thing to note within the enterprise also is that small cells are becoming more enterprise ready. Small cells are great. They're a great solution for a single operator to take care of a customer's issue that may be experiencing poor coverage or lack of mobile services in the indoor environment. The reality is the orange display on the left-hand side, legacy standalone small cells have typically been deployed. So here's a good example where we have 9 what we call radio points that are actually in fixed locations throughout a building. Each of these radio points has a fixed coverage footprint and only dedicate its service within those dedicated areas. The reality is when you have a multiple number of small cells within the building, each access point creates borders. And as a result, dead zones and handovers may occur. Now, capacity is fixed to each of these access points, so as a result, mobility is limited and usability is limited if you overload a certain area within an environment, within a real estate floor or an enterprise floor where employees may be working. Not to mention, since you have 9 individual radio points or small cells within the building, you introduce a complex RF design or complex approach towards the RF design. On the right-hand side, what we have displayed here is what we call a Cloud RAN or C-RAN type of solution. Now, what we're planning with this type of technology that's being introduced in a Cloud RAN environment, very similar in architecture. You basically have 9 individual radio points that are being displayed, but they all operate as a single cell with no borders. And as a result, no dead zones and no handoffs are occurring. Now, when we call Cloud RAN, what we're doing is we're pooling our ability to service multiple users in one location. And what happens is the capacity or the service will follow each user from each radio point. Hence, you're not limiting the capacity of the service within each radio point, but it follows it, the group of users amongst all the different 9 small cell radio points in the Cloud RAN environment. You could see from this perspective, since no dead zones and no handoff layers occur, you simplify the design and deployment, and the quality of service for the end user can be satisfied. Simplicity is a key here, so the important thing is, from an enterprise perspective, we want to make it easy to deploy. We want to make sure the class and quality of service is seamless for every end user moving around an environment. So mobility is completely supported from that perspective. Now, as we move towards the last section of the presentation, now that we've covered the various trends and challenges within the enterprise, right, and you've seen the tremendous growth as far as why in-building wireless systems are needed, and you also see the certain challenges that are being addressed from a cost and network operating complexity perspective, you can see that there's in-building wireless alternative solutions that will address some of those complexities. But then now you may be in a situation where you've analyzed all the different types of alternatives. You've realized that there is a tremendous need within your organization to provide some type of in-building wireless solutions. So now let's discuss, some recommendations for choosing the right in-building wireless solutions.
And before we get into that, Brian, as you know, we have a second poll set up, and we'd like to ask the audience to vote on that, please. It's on your screen right now. And please take a moment to cast your vote. Which technologies are deployed in the buildings for which you are responsible? Wi-Fi, DAS, small cells, or none? Please let us know what you have in your buildings. You can select all that apply. We'll show those results in a moment. And Brian, first I'll read out these results, and I do have a question for you, Brian, that you may want to address before you move on. Let's see, we have Wi-Fi, 81% of attendees have that, 19% with the DAS, and 11% for small cells, and none at this time. So before you move on, I did want to ask you a question that's come in that I believe certainly relates to what you've talked about already, but will be going forward as well. And that's, could you address the wireless access points in terms of sizing, spacing, locations within buildings that have different building materials? So how do those wireless access points and that infrastructure planning play in with different building materials that obviously are in place in many different facilities, such as concrete, steel, wood?
Yeah, that's a very good question. So first, when you look at materials that are deployed or used for construction with different buildings, obviously every building has construction material is different. The reality is, one thing to understand about mobile technology is that the solution that should be chosen is going to be impacted by the frequency range and at the same time what type of power is going to be emitted to really propagate that signal. When we talk about licensed frequency, every single operator out there has what we call low frequencies or high frequencies for the particular services. The reason why I'm explaining this is, independent of the operator, if services are deployed on lower frequency bands, the signaling tends to propagate or permeate a lot stronger, or can penetrate tough media a little bit easier. When higher frequencies are used, as a result, the higher frequency bands don't allow for so much permeability of that signal through buildings, or it doesn't allow the signal to transpose through media a lot more effectively. Now, as a result, based off of knowing that type of understanding of how frequencies propagate signals or send its signals through the air, you would have to design a network with more radio or access points if higher frequencies are being used. If lower frequencies are being used, you won't need as many of those wireless access points. So that's why when it comes to designing a certain network, there's a lot of preliminary work and studies that are done to understand what the current radio conditions or wireless conditions are for each of the service providers within each location, within each geographic location. And once that, what we call benchmark data, is analyzed, service providers and engineering firms then go ahead and figure out what type of services and what type of solution should be offered. So independent of the wireless access points, they now have to determine what type of access point power should be used. And that all translates to understanding the criteria as far as the number of service providers, the number of subscribers that need to be serviced, et cetera. But case in point, just in summary, lower frequencies don't need as many access points. Higher frequencies definitely will need a lot more access points. Okay. Hopefully that answers that question, Ann.
Thank you. Thank you.
Okay, very good. Well, the polling question is very, intriguing, and most importantly, it really helps coincide perfectly with the fact that Wi-Fi access points and Wi-Fi technology has been pervasive. It's a natural indication for any type of organization to utilize a core technology that's being used, but to understand what strengths and limitations it has. So Wi-Fi definitely has a great place, but as what was illustrated in the previous slides, it was really primarily used for a core data connectivity solution. But when we talk about enhancing mobility and voice and data services, it kind of has its limitations. Now, with that being said, the next couple slides I want to talk about the typical use case studies for DAS and small cells. And this ties into the polling questions as far as, well, what solution really works for me? So this chart here that I have displayed here has on the vertical axis going up the various frequency bands and service providers that are being used. And on the horizontal axis, it shows the number of users and the usage intensity. So case in point, if you're only talking about 10 employees or 10 people, all the way up to 100,000 plus, what type of solution should be used, all right? Now, starting in the lower left-hand corner of this graph here, a standalone small cell could be used to service, let's say, a home, a private residential area, a branch office, even a smaller retail shop or smaller restaurant. You can see how a standalone small cell operated by one service provider will definitely fit the bill. You know, personally, I have a small cell over in my house in Chicago, so there's a lot of reasons why there may be use for that in that particular area. All right. Now, when we look at the increasing demand on why you might want to scale up or scale up to larger solutions, that's going to correlate with the amount of frequency bands and the number of service providers that are going to be needed within certain applications. So when we look at larger buildings or large deployment areas such as hotels, hospitals, high-rise office buildings, a Cloud RAN small cell solution may be advised, but then again, similar to standalone small cells, these are single carrier type of solutions. Now, as capacity or usage increases within these particular buildings, the need to look for additional service providers may be needed. So as a result, instead of actually utilizing multiple small cells and independent, what we call layers of different radio technologies by each service provider, an enterprise DAS solution may be an optimal choice. Now, keep in mind, the enterprise DAS solution from day one will support multiple radio providers, multiple wireless service providers, and all they have to do is plug in their radios at the front end of an enterprise DAS system. So one universal access point that's radiating a wireless signal can now support multiple services and multiple subscribers. And of course, as you scale up into the large venue DAS environment, such as major airports and large stadiums, where usage is really large and the need to support multiple service providers is needed, that's where you scale and grow towards utilizing some type of large venue DAS system. Now, the next graph I want to share with you, as far as looking at different types of solutions, you know, when we look at in-building wireless, the key question is, how do we pay for this? How do we fund this? Now, overlaying in our analysis, just overlaying over the typical venues or applications where it would be used, whether it's a home office all the way up to a large stadium, there's two key funding environments that everybody on this webinar should understand. In the small to medium-sized space, between, let's say, 10 employees or 10 individuals within a building, up to about, let's say, 1,000 to 1,500, or let's say to about just under 10,000, an enterprise or building owner fund should be used to go ahead and own the actual system itself, all right? The reality is that not only based off of the number of users and usage intensity within these fixed locations and the number of bands and service providers, research is showing that there's over 200 to 250,000 of these buildings, if not higher, in the United States alone. So the mass quantity of these type of buildings are what's out there. And as a result, a service provider in a traditional model would help provide some type of cost offset to help mitigate that issue of the funding crisis. But the reality is now there's a shift where the enterprise is best suited by looking at utilizing their own independent funds to own and operate these type of DAS systems or these small cell systems. In larger scale areas, service providers or neutral host organizations who typically build on behalf of the service provider will invest their capital and expertise in the larger venues, major airports, large stadiums. Great example, if you travel for business like myself, and when you get off in an airport off of that plane and you power up that mobile phone, that signal that's reaching your mobile phone is provided by some type of neutral host operator working on behalf of a service provider. But think about the data traffic in a major airport. A lot of mobile subscribers in and out, transmitting and receiving signals from one point of the country to another, but at the same time traversing from a home city to another city. So that's very extensive as far as the network technology and network deployment strategies that would be used. Now, one thing that should be considered, and to close out the presentation, is now that you have a good understanding of the different alternative solutions, and you have a good understanding of how to fund or look and approach this, what I'd like to do in a very quick summary here is to show you what is involved with deploying an in-building wireless solution, right? There's 5 key areas when we talk about designing the system, deploying of the system, commissioning the actual in-building wireless system, optimization of the overall system, and maintenance of the platform. So there are various organizations that have expertise in each key area. When it comes to designing the system at the very start of the process, you need to find a partner that can be engaged for end-to-end serviceability, from designing all the way up to maintaining the system. Often at times, there are core experts that are responsible for doing the design, which is fine, but there are teams and people that actually do that. Modeling software is used typically at the design process to mimic the effect of sending a signal in building and seeing the impact of how it pervasively carries its signal through multiple buildings, right? When we talk about deployment, technologies have to be used in the in-building wireless solution that will manage power, infrastructure, and integration of the technology. Make the deployment of the system very easy to install and very easy to go ahead and integrate within an organization. When it comes to commissioning the system, commissioning means setting up the system in a proper way that can balance out the signal properly distributed by each service provider. So adjustments, either manual or automated, need to be done, and you want to make sure the in-building wireless solution has some type of software capability. From an optimization perspective, being able to control the interference, all right, or class and quality of service is very important. Above and beyond the first day that signal now works inside a building and is now providing seamless mobility coverage for every end user, lifecycle management is going to be extremely critical. So you want to make sure to utilize some type of in-building wireless solution that will make it very easy to optimize some type of network. And most importantly, when you're looking at lifecycle maintenance, day in, day out of the growth of the system, day in, day out of knowing that there may be issues with certain components on a DAS system, you want to make sure you find the right partner with the core expertise to make sure that they understand how to service the DAS system and to get the system operational. So in conclusion with this webinar, we've now covered every single aspect of an in-building wireless system, primarily for commercial areas. We talked about the research of the huge demand for wireless data services and seeing the impact to your enterprise. We gave you a good understanding of the different core technologies that are out there for utilizing wireless services in building. And last but not least, we also talked about some of the challenges and how to address those challenges, and to give you an understanding of how to fund this and what to experience, what you would experience as far as what this investment would entail when you're actually looking at deploying some type of in-building wireless system. So in closing, what I'd like to do is show you this last slide here that talks a little bit more information on in-building wireless. So our great organization, CommScope, has developed an in-building wireless best practice free ebook. All right, so we actually have the URL listed there, which is www.commscope.com/resources/ebooks. And what we have here is an extensive amount of information, over 50 pages, of different types of IBW technologies that have been compared, similar to what I presented to you today. There's deployment tips to give you an understanding of what's going on from an integration perspective to help maintain the systems or deploy the systems, and to help understand and justify the cost of these systems. Right? And of course, we give you a little bit of insight as far as the future market trends that are impacting in-building wireless systems. So I appreciate everyone's time right now, so I'm going to turn it back over to Ann for some questions and answers, I believe.
Great. Thanks, Brian. Thanks so much for the presentation, and thanks to everyone for listening in and for sending in your questions throughout. And yes, we do have a little bit of time till the new hour to go through some questions. So I'll jump right into that. Let's see. Okay, Brian, regarding service providers, is it common for each of the service providers to require their own separate backhaul, or can they share from one head-in point from outside the building?
That's a good question. At the end of the day, typically each service provider is going to have its own dedicated connection from their network to the building. Now, obviously, what's impacted every service provider, dating ourselves way back within the telco days, a local exchange carrier still owns the rights of that quote-unquote last mile connection to each building. So regardless if the local exchange carrier may be a competitor service provider, each wireless service provider is going to have its dedicated connection, and often at times don't have shared connections with other operators. And it's for proprietary reasons, because they need to own, maintain, and operate that dedicated link to that facility. So that needs to be managed under strict optimization and control by each service provider. Mm-hmm.
Thank you. So a more general question. Well, actually, no, we'll keep on that vein. In your opinion, do you see more single carrier or multi-carrier DAS systems?
Right now, very similar to what was interesting is looking at the poll questions that came about. As far as core technology, a lot of enterprises typically have Wi-Fi. It's natural behavior for organizations to lean on technologies that they're familiar with or that's readily available. Often at times, organizations statistically will have service that's given to you by one single operator. So as a result, if there's a true in-building challenge, the first course of action is for them to utilize a single operator solution. Now, what has happened is small cells typically make its mark and get introduced right away as a quick fix. But then once signal becomes pervasive and it becomes available, other carriers or their employees within an organization are going to want their particular service also to be maintained and operated within building. Then you have a quick switch over or evolution towards connecting to some type of DAS system and introducing that into market. So what we see typically is small cell first being introduced and then a very quick introduction of DAS because the demand now increases in the medium to long term.
Thank you. Okay, so let's see. We have a question about if the local AHJ requires a DAS system for emergency responders, how does that DAS equipment requirements change if the client still wants multi-provider cell equipment?
That's a great question. AHJ, typically authorities providing jurisdiction. That type of term is used for various public safety entities. Now, one thing to understand is majority of the systems that are deployed, DAS-wise and for small cells and core technologies, have been traditionally maintained for what we call commercial services, general public use, non-first responder, non-public safety. When you enter the world of public safety, there's other requirements and other technical features that need to be enhanced to really make sure that you have a pervasive public safety network on board there. Very interesting. I was in a customer meeting today just discussing this topic. And the reality is the most traditional approach is to have some type of overlaid network strictly for a public safety network. There's no mandate that states that a public safety network should be separate from a commercial network, but often at times that deployment strategy is typically what's engineered and designed to keep the layers separate. The reality is right now we're at the beginning point of public safety becoming a requirement. Organizations, federal organizations such as FirstNet are coming to market to try and standardize the marketplace to help define these requirements a lot more effectively. And as in all technologies, when you have a standards body, you want to make sure the equipment manufacturing and engineering practices coincide. So right now, there isn't one finite standard, but we see a mix of independent layered systems of public safety over commercial. And in some situations where there aren't strict guidelines, we have commercial and public safety on the same network. All right.
Wonderful. Thank you. Thanks for that. So a more general question, and I think we just have time for maybe one more here. So let's see. Is there training available in the industry that you're aware of, or classes for understanding the DAS technology and systems in more detail that our attendees might be able to take advantage of?
No, that's great. That's a great question. The last slide that I introduced is a great example of the demand for this type of knowledge. So from a training perspective, I know first and foremost, CommScope has a suite of different types of online training, free online training that's on our website. Through our e-catalog, you can actually research a bunch of topics and train yourself on understanding the technology and the different types of solutions that are there. But for those organizations that are trying to introduce DAS and DAS technology or small cell technology or in-building wireless technology to a technical IT staff, an organization like CommScope has training certification courses that go into the technical aspect of understanding the technologies and the equipment in a lot more detail. And even from a quote-unquote certification perspective, when DAS systems or small cell systems or in-building wireless systems need to be deployed, since CommScope is one of the largest equipment manufacturers out there, from a standards perspective, we drive a lot of the certification, and often at times that may be needed by entities to go ahead and approve certain type of DAS systems. And knowing that an individual or an organization is CommScope certified would definitely help out.
Great. Thank you very much, Brian. It looks like we are out of time, so I want to thank you again, and thank CommScope for sponsoring the webinar today.
Great. Thank you, Ann. I appreciate everybody's time and look forward to chatting again. Take care.
And thank you to our audience for attending today and for your participating in the polls and with the questions. A recording of the webinar will be available online at facilityexecutive.com. And we want to thank you again and have a great afternoon.